Welcome to another postgraduate workshop. So based on the information given to me, this is the postgraduate workshop number 9. So in this particular session, we are going to discuss about the nonlinear ARDL model, or nonlinear autoregressive distributed lag model. So basically, we are going to separate this session into two parts. The first part, in the first part, I will explain the basic concepts of ARDL as well as the nonlinear ARDL. In the second part, I'll try to show you the methods of conducting the NARDL analysis by using EViews. So talking about the EViews, I contacted the JTMK because I wanted to install the latest EViews software in my laptop. But unfortunately, they said that it can only be done in their office. So since we are in this, controlled movement order in UMS, so I cannot enter and go to the JTMK. So for that reason, for this particular workshop, I have to use the EViews version 9. So I hope that you are okay with it. But don't worry, because even though that the version that I have is not the latest version, because if I'm not mistaken, the latest EViews software is version 11. Yeah, but don't worry, even though it is different, but the difference is not that significant in terms of conducting the analysis, either by using the version 9 or using the version 11. Yeah, and it says here that this is a workshop specifically for postgraduate, but even though you are undergraduate and you still wanted to learn about the nonlinear ARDL model or NARDL, it is fine, it is okay. I welcome you to do so. And so while I'm in the presentation mode, shortly, if you have any question, you can kindly switch on your microphone, because I'm not really sure how we can see the meeting chat while I am in the presentation mode. Okay, and I hope that you can see my screen clearly. Oh, okay, so I can see the meeting chat. So in that case, you can either put your question in the meeting chat or chat box, or you can also switch on your microphone to ask.
Okay, thank you.
Thank you very much for the response. All right, so to begin our workshop, or to begin our session, let me first introduce myself. My name is Saizal Pinjaman, and I am a senior lecturer under the financial economics. And my topic of interest is econometrics, statistics, and financial economics. And if you have any question, you can also contact me through this email, saizal@ums.edu.my. So let us start our session with the basic concept of ARDL and NARDL. So we will try to understand what this autoregressive distributed lag model is and how we can relate it to the nonlinear ARDL model. So just like any other econometric analysis, it is very important for us to have an econometric model that is in the correct functional form. Yeah. So what we mean by correct functional form is that we need to select the appropriate variables, and these variables need to be in the most suitable format. Because if, say, for example, we have issues in the functions, either the way we select the variable or the way we use the format for the variable, then issues, okay, will happen to the estimation. And when we talk about the functional form, one of the most important consideration, particularly with time series data, is that we need to model the dynamics appropriately. That we need to model the dynamics appropriately with the most appropriate lag structure. So what we mean by dynamic model is that we include lag values. We include lag values in the right-hand side of the equation. So this is a very important uh, assumption when we conduct econometric analysis or economic analysis, particularly in time series and panel data. And talking about dynamic model and lag variables, a possible source of any problem with the functional form is the lack of a lag structure in the model itself. So it means that when we fail to include lag structure in our model, even though these lag structure are important in explaining the dependent variable, then our estimation will have a problem. It will have an issue. One of the issues that we can associate to the failure of including the lag structure is the problem of autocorrelation or serial correlation. So autocorrelation or serial correlation is an issue where the error term in our estimation is non-random. What we mean by a non-random error term is that our error term in the current value is influenced by the error term in the lag values. So one of the reasons why we have this autocorrelation and serial correlation problem is because we fail to include important variables, or in other words, our estimations suffer from omitted variables. And when we talk about omitted variables, one of the reasons why we have this issue is because we fail to include the lag structure or the lag values in the right-hand side of the equation. However, it doesn't mean that whenever we try to conduct the economic analysis, be it time series or penalty analysis, we have to use lag variables. No, because we need to have strong justification, either based on theory or based on previous research. Are there any questions so far?
No question.
Okay, thank you. And talking about lag, there are three types of lags in the model. First is the autoregressive lag, which refers to lags in the dependent variable. So another type of lag is called the distributed lag, which refers to lags of the explanatory variables. And the third type of lag is called the moving average, which refers to lags in the error term. But of course, in this particular workshop, our attention will be towards the first two lags, namely the autoregressive as well as the distributed lags. So we go to the ARDL model, which is the what we call as the fundamentals of the NARDL itself. As you can see on the slide, before the existence of the ARDL model to analyze the relationship among different variables, we basically use the vector autoregressive model as well as the vector error correction model to estimate the relationship between the variables. But for these two models, VAR and VECM, we assume that the variables are stationary at the same order of integration. So the difference between VAR and VECM is that the VECM, or vector error correction model, is the restricted version of the var itself, where the variables that are stationary at the first difference are co-integrated, while VAR, the vector autoregressive model, on the other hand, is used when the variables that are stationary at the first difference are not co-integrated. And of course, it is worth to mention that when variables are stationary at level or I0, then the simple OLS regression can be used to estimate the parameters of the variable. So I hope that all of you here have some basic understandings on econometrics, because we are going to mention econometric terms quite significantly in this particular workshop. So, okay, as you can see from the slide, in many cases, particularly financial data, not all variables are stationary at the same order of integration, or more specifically, integrated at the first difference, or stationary at the first difference. So this leads to the formation of the ARDL model. So this ARDL model solves the problem of autocorrelated error that is suffered by finite distributed lag model. So besides that, the ARDL model also able to analyze causal relations for variables in different order of stationarity or different order of integration. And keep in mind that this ARDL model, okay, the estimate of this ARDL model for the long run coefficients are also consistent whether the regresses are all I0 or stationary at level, stationary at the first difference, or a mixture of the two situations, stationary at level and stationary at the first difference variables. But basically, we use the ARDL model when our variables exhibit different level of stationarity. So the estimation of long-run relationship between the variables by using the basic ARDL PQ model is shown in equation 1, where you can see there that our dependent variable is explained by an intercept, a dependent variable at the present period of time, as well as the dependent variable in lag values from lag 1 to lag Q in this case. Apart from that, you can also see that in the ARDL model, in the ARDL model, we also include the lag values of the dependent variable itself, which is in this case y, from lag 1 to lag p. So this is the reason why we call this model as the autoregressive distributed lag. Because why? Because we have two types of lag in this case. First is the autoregressive lag, where we include the lag of the dependent variable itself. And another type of lag that we have in the model is the distributed lag, which is the lag value of the dependent variable, in this case, x. So x is a set of independent variables that we include in the right-hand side of this equation. And this equation 1 can then be rewritten into equation 2, where you can see here that the dependent variable is a function of a constant term. The difference of the dependent variable in lag values, the difference of the independent variables, or the difference in the independent variables and in their lags. And we also include the lag value of y, which is the lag value of the dependent variable, and then the lag value of the independent variable. So, of course, in estimating the ARDL model, it is very crucial for us to obtain optimal lags. And there are a number of ways for us to estimate the optimal lags in the ARDL models. Yeah. Our lags is written or shown based on the value of P and Q. And two of the most popular ways to estimate the optimal lags in the ARDL model is the Akaike info criterion and the Schwartz criterion, the AIC and the ACE. So if we look into the equation number 2, this symbol here, it represents the difference, while this is our error term, and the alpha, theta, beta, and the two lambdas are the coefficients that need to be estimated in the analysis. So in order to identify the existence of a long-run relationship, we can conduct the Saran et al. Bound test, where based on this test, the null hypothesis states that the lambda values here is equal to 0. So it means that in the null hypothesis, we assumed the non-existence of long-run relationship among the variables. If we reject the null hypothesis, then we can conclude that there is an existence of long-run relationship among the variables. So we reject the null hypothesis when the value of the F statistic is higher than the upper bound, and the rejection of null hypothesis indicates that there is a long-run relationship between the volatility of economic sectors here, between the variables. Sorry for this one. I retrieved this based on my note, yeah. So are there any questions so far?
Excuse me, teacher, I have a question.
Yes.
I want to ask, in a model, if one variable is I0 and another variable is I1, and then what model can I use to results?
I'm not really sure whether I hear it clearly or not, but are you saying that if in the model we have variables that have different stationarity level, what is the most suitable model that we can use? Is that
Yeah,
your
yeah,
question?
yes.
Okay, if we have that situation, we can use the ARDL model, because just like I said before this, there are situations where our variables have different stationarity level, where some are stationary at level and some are stationary at the first difference. So in this case, we can use the ARDL, but keep in mind that the ARDL model can only be used when our variables are I0 and I1, and it cannot be extended to I2. In other words, say, for example, there are variables that are stationary at the second difference. So in this case, we cannot, or we no longer be able to use the ARDL model. So that is an important assumption of the ARDL model as well. Excuse me, I think one of the participant accidentally opened his or her microphone. So can you kindly switch it off?
Yes, I can hear you. Thank you, teacher.
Okay, thank you very much. Also, I hope that I answered your question. Yeah.
Okay, thank you.
So welcome again. As I mentioned before this, in this particular workshop, we are going to discuss econometric terms quite significantly. So I hope that all participants here have basic understandings in econometrics. Okay, so do we have other questions? So I cannot hear you clearly. So can you put the question in the chat box? Yeah, so that I can see it clearly and we can address it properly.
Okay, thank you.
Welcome. So I think some of the participants accidentally switched on the microphone. So can you kindly switch it off? So I'm not really sure whether I can do it here or not. Yeah. Okay, so can we proceed? We proceed to the error correction model, which is an extension of the ARDL itself. So in the error correction model, we will test or we investigate the short-run relationship of the variables. Okay, so here, the error correction model can be represented based on equation 3, where, as you can see, the dependent variable is a function of a constant term. The difference of the dependent variable in lag values, the difference of the independent variable in present as well as in the lag values, as well as the error correction term in lag value. So the error correction term there represent the speed of adjustment for the model to reach equilibrium or long run relationship. So the error correction term or the ECT shows us or tells us the rate of adjustment of the model when shocks happen in the variables in period by period. And in order to conduct the error correction model, we can use the least square estimation. Yeah, the ordinary least square estimation can be carried out to analyze the ECM model. And just like the ARDL model, in order to choose the lag values in the model, represented with P and Q here, we can use a number of coefficients, including the AIC and the ACE, a Kaiki info criterion and Schwartz criterions. So the ARDL model and in extension, the ECM model can be analyzed further to identify whether the model is acceptable or not. So there are a number of diagnostic tests that we can run to uh, determine whether our ARDL model and the ECM model are correctly specified. So one of them is, of course, the heteroscedasticity test. And in identifying that our model is homoscedastic, homoscedastic means the variance of the error term is constant across time. So this is an important and significant assumption for time series data and panel data as well. So one of the tests that we can use to detect heteroscedasticity issue in our ARDL as well as the ECM model is through the Bush-Pagan-Lagrange multiplier test. And say, for example, that our model is heteroscedastic. Heteroscedastic means that the variance of the error term is non-constant across time. Keep in mind that in terms of the error term for the model, we not just assume that the error term is random, we also need to assume that the error term is constant. Yeah, in fact, it is one of the part of randomness. So say, for example, that our model is heteroscedastic, then we need to use the robust standard error. This is because when our model, be it in the ARDL or ECM, if they are heteroscedastic, it means that the standard error retrieved will be non-accurate. So that is the reason why we need to use the robust standard error. And among the robust standard error that we can use is the wide robust standard error. So this is one of the popular methods to achieve or to obtain the standard, to obtain the robust standard error of any model, which is the wide robust standard error. Another diagnostic test that we can conduct is the stability test. Yeah, where we can run the CUSUM test. Yeah? CUSUM refers to the cumulative sum of square tests. So under the null hypothesis of coefficient constancy, the values of the sequence outside an expected range suggest structural change in the model over time. Yeah, it means that the CUSUM will test whether our model is stable or not over time. So that is the reason why it is important for us to conduct this stability test in the ARDL model as well as in the ECM model, which are time series data. And apart from that, we also need to conduct the serial correlation test by using the Bush-Godfrey serial correlation Lagrange multiplier test. So this is one of the tests that we can do to identify whether our model contains serial correlation or not. So as I mentioned before this, Serial correlation means that the error terms are correlated across time. It means that the present error term is explained by its lag values, means that it is no longer random, which is a very important assumption in ARDL model and in the ECM model. So say, for example, we have this problem in our estimation, then we need to check for omitted variables. We need to check for omitted variables. This is because one of the reasons why that our error term is non-random, or in other words, the reason why that the present error term is determined or influenced by the previous error term is because we failed to include important variables in the estimation. Since we failed to include these important variables in the estimation, the impact of that variables will be recorded by the error term. Thus leads to an error term that is serially correlated. So we have to check for the omitted variables. Yeah. So one of the reasons why we have omitted variables is because our model failed to include dynamic nature of the relationship between the dependent and the independent variables. Of course, it depends on situation. Yeah, you can refer either on theory or you can also refer to the previous literatures to identify the dynamic nature of the estimation. So when we relate this serial correlation problem to ARDL and ECM model, we may suffer from serial correlation if we fail to include the asymmetry of the variables. Remember, we have dynamic variables and we also have asymmetric variables. So we will try to discuss a bit about asymmetric variables after this. And another test that we can conduct is the specification test by using the Ramsey reset test. So the Ramsey reset test or reset test itself stands for the regression equation specification error test. So that is what reset here stands for. So the Ramsey reset test tests whether the nonlinear combination of the fitted values help to explain the response variable. So if it helps to explain the response variable, it means that our model is incorrectly specified. So we have to use the nonlinear combination then. So here you can see that if we have that problem, if we have misspecification, then we need to check whether we can conduct the NARDL itself, which leads to the concept of nonlinear ARDL model. So before we continue with this part, let me see first if we have questions in the chat box. So I hope that this session is recorded, yeah, because I'm not really sure if, yeah, okay, this session is recorded. Okay. We proceed with the NARDL model. So remember that this NARDL model is an extension of the ARDL model itself, where in the nonlinear ARDL model, we include the asymmetry of the dependent variables in our estimation. So here you can see, based on the slide, it is important, yeah, for us to include all the relevant variables in the model. Otherwise, we may suffer from problems such as serial correlation. Because if we exclude important explanatory variable, then the regression has what we call as omitted variable bias, which may lead to problems like serial correlation, heteroscedasticity. Yeah. So this means that the estimates are unreliable and that the t-test as well as the f-test or f-statistics and t-statistic cannot be relied on. So if we cannot rely on the t-statistic and f-statistic, it means that we cannot make conclusion on the relationship, or we cannot make inference on the relationship between the dependent and the independent variable, as the relationship is tested by using the t statistic and the f statistic. Yeah, we conclude the relationship between the dependent variable and the independent variable by referring to the t statistics and the f statistics. If we cannot rely on the t statistics and f statistics due to the omitted variable bias, it means that we cannot conclude the relationship between the dependent and the independent variables. So equally, there can be a problem if we include variables that are not relevant as well. Because if we include variables that are not relevant, it may reduce the efficiency of the regression. Because keep in mind that when we run the regression, we include all variables in the model. When that model is estimated, all variables will be included, including the non-relevant variables. So since we include these non-relevant variables in the estimation, the efficiency of the efficiency of the regression or estimation will be reduced. Yeah. However, this is not as serious as the omitted variable bias itself. And of course, one of the way for us to test whether our model is correctly specified or not is based on the Ramsey reset test, just like I said before this. Yeah. So this Ramsey reset test is a popular method to be used to determine if the functional form of a model is acceptable or not. So keep in mind that the Ramsey reset uh, test whether the nonlinear combination of the fitted value helps explain the response variable. So one of the elements or nature of the dependent variables as well as the independent variables that we need to take into account is the asymmetry of the variable itself. Yeah, asymmetry here means that the negative values as well as positive values of the variable have different impact towards the dependent variable. So here you can read that the common assumption that the underlying co-integration relationship may be represented as a linear combination of the underlying non-stationary variables may be excessively restrictive. Sometimes if we impose a linear combination of the non-stationary variables, it may be too restrictive. In other words, some of the non-stationary variables are non-linear in their relationship. So when we include the asymmetries, when we include the asymmetries, it may help us to understand more about the relationship between the dependent and the independent variable. So in the long run, in general, the long-run co-integrating relationship can also be subject to asymmetry or non-linearity. So asymmetry and non-linearity represent the same meaning. Yeah, it means that positive values of a set of independent variables and negative values of a set of independent variable have different influence towards the dependent variable itself. So here you can see that the dependent variable is a function of a set of positive independent variable and a set of negative independent variable. So the NARDL or nonlinear ARDL model is a unified model that capable of combining nonlinearities in the long-run relationship and the error correction mechanism coherently. And as I mentioned before this, the NARDL is an extension of the well-known ARDL model of Pesharan in Shin, as well as Pesharan et al. So we use the NARDL to capture both the long run and short run asymmetries in the variable of interest. So just like the ARDL itself, the NARDL can be used to study the short run relationship and the long run relationship of variables that have different asymmetries. So consider the following asymmetric long run equation. So here you can see that this equation is pretty much the same as what we have in this slide, where in this equation 4, we have the dependent variable, which is explained by a set of positive independent variables and a set of negative independent variables. Yeah, a set of independent variables in their positive values and a set of independent variables in their negative values. So the positive values and negative values have a different impact towards the dependent variable. And when we try to study the long run relationship of these asymmetric independent variables, we are going to look into the coefficient values. So here, the beta in positive notation and beta in negative notation are associated long-run parameters that we need to estimate in the model. So the positive annotation and negative annotation of the independent variables are partial sum processes of positive and negative changes in the independent variable. So here you can see that we have these partial sum processes for both independent variable in their positive value and the independent variable in their negative values. And when we use the equation for what we have here into the ARDL model, or when we frame the equation for in ARDL setting, we will be able to form this equation as you can see on the slide. Yeah, here we can see that the dependent variable is explained by its previous value, the independent variable in positive value, the independent variable in negative value, the change of the independent variable in lag, the change in dependent variable in their lag values, as well as the change of the independent variable, both positive and negative. So we refer to this summation notation to measure the short-run influences of increase in the independent variable, as well as the short-run influences of reduction in the independent variable. So we looked into the notation to study the short-run relationship, while we can refer to the theta values over here to study the long-run relationship. So any question? Any question, anyone? Before we proceed with some practicals of the NARDL itself. Hello? Yeah, I believe that there is a participant who wants to ask a question. Yeah? You can also put your question in the chat box if you want.
Okay, no question. Thank you,
No
teacher.
question? All right. So in that case, let us proceed to the practical part of NRDL. Or do you want to take a break for maybe 5 minutes? Yeah. Anyone want to take a break?
Okay.
So in that case, let's take a break for 5 minutes because I think we have discussed for around 15 minutes already. So let us take a break for 5 minutes, and then after that we continue with the practical part of NARDL. Okay. So
Okay.
now we are at uh, let me see. We are now at 9:57. So let us continue at let us continue at 10:05. Yeah, 10:05. Of course, if you have any question while we are taking a break, you can also put your question in the meeting chat. Okay, let's continue our discussion. So before we go to the practical part, let me first show you the difference in terms of ARDL model as well as the ARDL model. What is it that we modified in the ARDL model to form the NARDL equation? So take the highlighter first. So as you can see here, this is our ARDL model. Yeah. And in this ARDL model, the dependent variable is a function of itself, yeah, in difference form in the lag values. Yeah. So our dependent variable is a function of its difference form in lag values. The difference form of the independent variable in lag values, as well as the dependent variable in lag 1, as well as the independent variable in lag 1. So this is the ARDL equation. If we compare it with the NARDL equation, just like what we have in this particular part, we can see that there are some modifications. Yeah, there are some modifications where in this situation, the dependent variable is a function of its lag 1 value, lag 1 of the independent variable in positive values and in negative values. So this is one of a number of changes in the equation for the ARDL model to form the NARDL. Because in the ARDL model, we don't have the asymmetry of the independent variable included in the equation. But in the NARDL, we include the asymmetry of the independent variable as part or to form the NARDL. Apart from that, you can also see that we have this different dependent variable in lag values. So this is the same as in ARDL model. And another modification is that in here, in the NARDL equation, we can put this equation as equation 7. Yeah, sorry, because I failed to include it before. So here we can also see that we include the asymmetry. Yeah, we include the asymmetry of the independent variable as well to see how it can influence our dependent variable. So modification number 1 and modification number 2, if we can call it modification. Yeah. So this is how we frame the asymmetry of the independent variable in the ARDL model to form the NARDL model. Yeah. So just like I said before this, to study the long run relationship, we are going to look into the theta values. While to study the short run relationship, we are going to study the what we call as the summation notation of the independent variable. In this case, we are going to look into the value of the pi in positive notation and the pi in negative notation. Okay, let us go to some practical discussion. So let me stop from sharing my screen first to go into the document or to open the document. Okay, here we have another question here. How if the diagnostic how if based on the diagnostic we have heteroscedasticity and serial correlation problem, can we still run the model? In that case, we cannot use the results obtained from a model that has heteroscedasticity and serial correlation problem. Yeah, it may indicates that we have misspecification, or we may have what we call as a omitted variable bias in the estimation. So you have to revise your model. Maybe you fail to include some of important variable, or you misspecified the variables. In other words, the variables may have asymmetries. Yeah, the variable may have asymmetries, or it can also be that the model is dynamic in nature. So when we talk about omitted variables, yeah, and misspecification, these are the things that we need to look into. One, we fail to include important variables. Second, yeah, we misspecified the variable itself. Yeah, maybe the variable is asymmetry, or maybe because we fail to include the dynamic nature of the variable itself. Means that we fail to include the lag values, be it the independent variable or the dependent variable in the right-hand side of the equation. Yeah. And apart from that, when we run the econometric analysis, we need to determine whether our model is static or dynamic. Yeah. Static and dynamic are very important assumption in the econometric model. So when we include lag terms or lag values of the dependent variable as one of the explanatory variables, or in the right-hand side of the equation, it means that we are conducting a dynamic model. Static, on the other hand, means that we are looking into the present value of the independent and dependent variable itself. In other words, that when we don't include lag values, it means that we are conducting a static model of analysis. Okay, let me open and share the screen. Okay, right. So here we have this particular data. Yeah. So in this particular data, we have three variables. We have FP to represent the food price, our GDP to represent the real gross domestic product, as well as the WTI, the West Texas Intermediate, to proxy the oil price. And based on the data, you can see that this is a time series data from 1971 until 1995. So around 25 years of data. So we are going to conduct the NARDL model by using EViews version 9. Yeah. So of course, just like I mentioned in the earlier part of the session, that yeah, I did not manage to install the latest version of EViews. This is because when I contacted JTMK, they said that they need to go to their office or to their building in order to install it. It cannot be done online, like SPSS, for example. So yeah, so I said that in this case, I have to proceed with the version 9, but don't worry, because there are small differences in the estimation for version 9 in the latest one, if I'm not mistaken, version 11. So you don't have to be worried, yeah? Because the most important part in the discussion is to understand the NARDL itself and how we can run this analysis by using the EViews. So let us open an EViews 9. Of course, I hope that you are familiar with EViews. Yeah. And okay, if we can explain, if I can explain about how we can export, say for example, you don't have sufficient knowledge you don't have sufficient knowledge about EViews. So in the EViews, we can export the data based on various ways. One is to create, one is to open an existing work file, or we can also open a foreign file. Yeah. In this case, we are going to open a foreign file, which is in the form of Excel. So in order to export it, you can simply drag. You can either click and then after that export. Sorry, import file, not export. Yeah, import file. Sorry for that. Or you can also simply what we call as a click the file that you want to import, and then you drag it in the EViews, and you drop the file there. And then you can choose next, next. Hope that you can see the screen clearly. Yeah. And then here, just click finish. And link imported series and alpha objects to external source. You can say no in this case. Yeah. All right. So this is our variable in the form of EViews. So we have food price, we have real gross domestic product, and we also have the fuel price here. And you can also see that constant term is automatically included, as well as the time period from 1971 to 2012. 2012, I thought it's 2005. And in this case, what we're going to do is to study how the fuel price is explained by the real gross domestic product and the fuel price. Yeah, so that is basically what we are going to do here. So since this is the time series data, so you have to run the unit root test first in order to detect whether the variables are stationary at level or the variables are stationary at the first difference. If the variables are stationary at a level, then you can proceed with the ordinary least square. Remember that. But if, say, for example, that the variable are stationary at the first difference, means that all the three variables, food price, gross domestic product, real gross domestic product, and fuel price, if they are all stationary at the first difference, yeah, I1, it means in that case, you have to run the co-integration test. Johansson co-integration test is one of the popular methods to determine whether the variables are co-integrated or not. Yeah. So if the variables are co-integrated, it means they have a long-run relationship. When they have long-run relationship, you can conduct the analysis by using the vector error correction modeling. On the other hand, when the variables are not co-integrated based on the co-integration test, then you can proceed with the VAR model, yeah, vector autoregressive model. On the other hand, just like I said in the early part of our discussion, sometimes we may face situation where our model or our variable have different stationarity level, where some of them are 0 or stationary at level. It means that they don't have unit root at level. And some of them are stationary at the first difference. Means, and in this situation also, we need to assume that none of these variables are stationary at the second difference. So if we have this situation, then we can proceed with the ARDL model. Remember, the NARD, before we go to the NARDL, we need to run the ARDL model at first if we are using the EViews, because the NARDL is an extension of the ARDL model. We basically frame the asymmetry of the independent variable in the ARDL to form the NARDL. Yeah, so if I'm not mistaken, I saw some question there. Can you use Stata to do the ARDL model? Yes, we can use Stata as well to run the ARDL model as well. Yeah, but in this case, we are going to use the EViews. Okay, so let us go back to the Excel because I wanted to see the variable again in the Excel form. I thought it is until 1995, but it is until 2012. Yeah, so we have around 42 years, not 25 years. Okay, sorry for that mistake before. So over 40 years, in this case, 42 years. So that is why you can see here we have 42 observations from 1971 to 2012. Okay. As I mentioned before this, to run the NARDL analysis, first thing to do is to conduct the ARDL analysis. But make sure to uh, conduct the what we call as a unit root test first. Yeah, you have to conduct the unit root test before you can proceed with the ARDL model, because ARDL model itself has what we call as important assumptions in terms of the stationarity of the variable, just like I said before this. Yeah, so let us assume that all of the assumptions leads us to conduct the ARDL analysis. And in order to conduct the ARDL analysis, let us change our variables into natural logarithm at first. Yeah. So here we have the food price. And in order to change the variable in the natural logarithm, you can use the command function, or you can also click quick and click generate series. Okay. Here they are both will produce the same result, where they are going to generate new variables based on the equation that you included. So say we wanted to log transform food price into natural logarithm. So, and we want to name that new variable. Yeah, we want to name that new variable as LFT to represent log food price. Okay, so and then after that, here we state that log food price, yeah, not fuel price, yeah, log food price is a function or equal to log value of the food price itself. And then after that, you click OK. Here you can see in our work file, yeah, we have a new equation, which is the log transformation of the food price itself. Yeah, the natural log transformation. Another method, apart from using this generic series function, is for us to put it in this command function. Yeah, to put the equation in the command function. In order to do so, we can also put generate series for, in this case, since we already included or generate the new variable for food price, which is in the natural log form. Now let us continue with the log transformation of real gross domestic product. Yeah. So we generate a new variable, which is the log real gross domestic product. So generate LRGDP. So that LRGDP is the log transformation of real gross domestic product. And then after that, you click enter. So here you can see that we have the we have another new variable, which is the log transformation of the real gross domestic product. Yeah. Let me double check first by using my scientific calculator if this is the exact log transformation or in natural logarithm or in a different base or in a different form. 6060434.41. Okay, so yeah, based on my calculation using scientific calculator, this is the logs transformation in natural log. Yeah, the natural log transformation of the real gross domestic product. This LRGDP is the natural log transformation of the real gross domestic product. And then after that, we can proceed with the third variable of interest, which is the fuel price. So we generate the log for fuel price, LWTI, we call it, when we name it, equal to log for World TI, yeah, Western or West Texas Intermediate. And then just like before this, we click the enter button. So we have LWTI. Okay, if you have any question, you can also switch on your microphone. You can put it in the chat box. So after that, yeah. After that, we can proceed with the ARDL model. But keep in mind that when we use the ARDL model, we need to ensure that all of the assumption leads us to use the ARDL model. Because apart from the ARDL models, there are a number of alternatives, just like I said before this. Yeah, it depends on the situation, it depends on the condition of the variable. You may use LS, you may use VAR, or you may use VACM and any other alternative methods apart from the ARDL model. So keep in mind that the assumption supports the use of ARDL model. Okay, so let us assume that based on the assumption, we need to use the ARDL model. Yeah, so here we can proceed with the ARDL estimation. So of course, our dependent variable is the food price in natural log, and our independent variables, or the variables that we're going to put in the right-hand side of the equation. Remember that the equation can be divided into two parts or two sides. So this is the left-hand side. This is the right-hand side. So that is what I mean by the words right-hand side and left-hand side of the equation. Okay? All right. So here, we choose the food price first because this food price is treated as the dependent variable. We wanted to study whether the gross domestic product and fuel price can influence the food price or not. So food price is in the left-hand side of the equation, while GDP and WTI, yeah, gross domestic product, as well as fuel price will become the independent variable. So we are going to put it into the right-hand side of the equation. So once we select the variables, we can choose, or we can click, or we can right click our mouse, and then after that choose open, and then choose as equation. Here, this is one of the methods, okay, to run the equation estimation. Apart from that, you can also click quick button and then choose estimate equation. But in this case, you have to type the equation on your own. Yeah, it is okay for us to use this if we have, a small number of variables. But imagine if we have huge number of variables, then it will be quite, quite tiring, quite complicated for us to use the manual method of equation estimation. So we refer back to the previous method where we choose the food price, GDP, and fuel price. So remember that this variable is in their natural logarithm form. Yeah, so we run the ARDL model based on the natural logarithm form of the variables, independent and dependent variable. So right click, choose open as equation. So here we have the variables, and you can also see that the EViews will automatically include the constant term. You don't have to include it because it will be automatically included by the EViews. Here, in the estimation setting, choose the ARDL model. Yeah. Okay. So you will be directed to this new form of equation estimation. So you can either have automatic selection or fixed selection of the lag values for the dependent variable and the regressors. But in our case, we choose automatic selection, and we set the maximum number of lags for the dependent variable and the regressors into 4 lags. So this is the default choice for EViews. So we leave it in that way. Apart from that, when you look into the options, you can see that we have various model to determine the optimal lag for this ARDL model. We can either have the Akaike info criterion, we can have the Schwartz criterion, but in our case, let us use the AIC. Okay, and then after that, here you can change the trend specification to non-linear trend. In our case, let us put it into level or constant. And here you can see that the sample in terms of time series is from 1971 to 2012. Yeah, so 42 observations. We click OK. Here you can see that we have the ARDL estimation for the variables. So here we have various information. For example, the number of observation is now 40 after adjustment. So EViews will automatically adjust the number of observations. So the maximum number of lags that we used before this is 4, and we use a Akaike info criterion to select the optimal number of lags for our ARDL model. And the fixed regressor is the constant term. And you can also see that in this case, our ARDL model is ARDL 210. What we mean by this is that our model, our ARDL model, chooses 2 lags of the dependent variable as the additional independent variable, 1 lag, okay, for the GDP. So here you can see GDP at the present value and GDP in lag 1. And you can also see here that we have 0 lag for the third regressor or for the third independent variable, which in this case is the fuel price. So fuel price has no has no lag value. So that is why here it states that the lag value for fuel price is 0. Okay. So after that, we can run the ARDL model, or we can proceed our estimation to find the long run form. Yeah, we can proceed the ARDL estimation to find the long run form. Yeah. So here for integration and long run form, once you click this choice, you will be directed to this result. Here we have the long run coefficient for gross domestic product and fuel price. And you can also see that we have probability values for the GDP as well as the fuel price. Means that this probability value can be used to determine the significance of the gross domestic product as well as the fuel price in the long run. If we use 10% significance level, here we can see that our probability value is smaller than 10% significance level. So in that case, we can conclude that gross domestic product and fuel price are significant in explaining, the fuel price, significant in explaining the food price in the long run, where based on the coefficient, both exhibit positive relationship with the food price, as the coefficient values are both positive. And based on this, you can also see that the coefficient value for gross domestic product is significantly larger or higher compared to the coefficient value of the fuel price. It may imply that GDP is dominant in influencing the food price compared to the fuel price. So we can extend this ARDL model to form the ECM analysis. But let us save that part for the NARDL, because remember, we are now in the ARDL form. So let us rename this work file into or object as ARDL1, because we are still in the ARDL estimation. Click ARDL model. And if we want to proceed, with the error correction model, this co-integration equation information is very crucial for us to take into account. But let us save it for the NARDL itself, because the estimation or the method to estimate the long run as well as the short run relationship are the same for both ARDL and ARDL. For both ARDL and NARDL model. So we are now going to proceed with the short run analysis for the ARDL model. We will proceed to the NARDL before we analyze the short run as well as the long run relationship between the variables. They are the same, so don't worry about that. So apart from that, based on this ARDL model, you can also run the diagnostic test, just like I mentioned before this. So you can click view, and then after that, you click residual diagnostic to check for heteroscedasticity and serial correlation. And apart from that, you can also run the stability diagnostic for Ramsey reset test. So if we run the serial correlation test, for example, so we include two lags here. What we mean by this is that we try to determine whether the present value of error term is influenced by lag 1 and lag 2 of the error term itself. So that is what it means by including two lags in this specification of the serial correlation test. So we click OK. So we looked into the probability value for F statistic and chi-square. So here you can see that the probability value is higher than 10%. Since it is higher than 10%, we can reject, we fail to reject the null hypothesis of non-serial correlation in our model. In other words, since we fail to reject the null hypothesis as the probability value is larger than 10%, we can conclude that our model is free from serial correlation. So you can continue with this heteroscedasticity test. Here you can run the Bruch-Pagan-Godfrey test. We have various types, but let us use the Bruch-Pagan-Godfrey test. So make sure before you choose specific type of any test, be it serial correlation, heteroscedasticity, make sure you understand what does that specification represent. So click OK. We use Bruch-Pagan. Here, unfortunately, we have this heteroscedasticity problem. We have this heteroscedasticity problem because why? In this case, based on the probability value, based on F statistic and chi-square, we reject the null hypothesis of homoscedastic model. In other words, our model contains heteroscedasticity. Heteroscedasticity means that the variance of the error term is non-constant across time. Yeah, it non-constant. It is non-constant across time. So it may jeopardize the what we call as probability value. As it jeopardizes the probability value of this estimation, this, yeah, as well as the standard error. So the conclusion that we make in terms of the relationship between the dependent and the independent variable will be inaccurate, if we can use the word inaccurate. Okay, so here we have that problem, and we can extend with the Ramsey reset test. We use, in this case, the number of fitted terms as 1. And here you can also see that the probability value for both T statistic and F statistic is smaller than or below than. For that, we reject the null hypothesis of correct specification for the model. In other words, we have misspecification in our estimation. So these may suggest that our model has asymmetry. Our model is non-linear. Yeah, it may suggest that. Yeah, it may suggest that our model is non-linear. And in order to strengthen your argument, to use the NARDL, because remember, when whatever methods that we use, be it ARDL, VAR, VECM, OLS, or any other methods for time series, and not just time series, but for cross-sectional and panel data as well, we need to have strong justification of using the specific model. Yeah, so in this case, in order to strengthen your argument, apart from conducting the Ramsey reset test, is by referring to the theory and what previous research say about the relationship between the variables. Yeah, if, say, for example, the theory, previous research also indicate that there is an asymmetry in the relationship between the dependent and the independent variable, then, yeah, then you can proceed with the NARDL model. And of course, apart from that, you can also refer to the Ramsey reset test, because here it says that this model is this model has misspecification. Remember the Ramsey reset test? Yeah, the Ramsey reset test tests whether the non-linear combination of the fitted value help to explain the response variable. So based in this case, it seems to suggest that we have a non-linear relationship between the independent and the dependent variables. Okay, so for that, we proceed with the NARDL. So I know that in the ARDL model, we can extend this to the ECM model to understand the short-run relationship, but we are not going to do that in this, what we call as model. This is ARDL model, because we will run the ECM analysis by the NARDL platform later on. They are the same as in the ARDL platform. So understanding how we run the short-run analysis by using NARDL will help us to understand how do we run the short-run analysis using the ARDL model itself. This is so that we can save time, okay? So any questions so far? So Madam Elizabeth say that please unmute your mic if you have any question. So hope that everything is clear so far. So we proceed. Now it's 10:44 already. We're supposed to end at 11. Sorry for this, prolonged session. So we proceed with the NARDL model, because based on the Ramsey reset test, our model contains non-linearity. Our model contains misspecification. So we have one question, if I'm not mistaken. regarding lags to include in serial correlation, any meaning of lag 1, 2, 3, or 4, and 8. So just like I said before this, that lag 1, 2, 3, 4, and 8 means that when we're referring to the serial correlation, okay, when we're referring to the serial correlation, okay, if we can show it here, we put the diagonal, click view, we are in the ARDL platform or ARDL model, click view, and then after that, here we run the residual diagnostic. So here you can see that it used the words residual diagnostic. What we mean by this, that all of that specification, heteroscedasticity, serial correlation, they are based on the residual. They are based on the error term. Okay, we are looking into the error term specification. So here, or the nature of the error term. So here, if we run the serial correlation, we can include a number of lags. Yeah. So what does these lags mean? So these lags mean we wanted to see how many lags in the error term that influence the present error term. Yeah. So if we use two, for example, basically we can simply include two lags because this is the default choice for ARDL model. Yeah. Sorry, for the EViews. You can include 3, 4 lags, but two is fine. Yeah. Two lags mean you include two lags in the error term to see how it influences the current error term. So that is how it means. So say, for example, here you include two lags and you click OK. And here you see that the probability value is higher than 10%. It means that we fail to reject the null hypothesis. What is the null hypothesis based on this Bush-Guthrie serial correlation Lagrange multiplier test says? The null hypothesis states that our model does not contain serial correlation. It means that lag values of the error term does not determine the present value of the error term itself. Since we're using two lags, it means that two lags of the error term will not influence the current lags. Will not influence the present value of the error term itself. The error term in 2015 is not influenced by the error term in 2013 and in 2014. So that is what it means if we are using annual data. Since in this case, of course, we're using annual data as well. Okay, so that is what the serial correlation test represent. Okay, so yeah, we proceed because we are running out of time already. So we proceed with the NARDL model. Okay, remember we are still in the ARDL model, and the NARDL is just an expansion. Yeah, we simply frame the asymmetry of the variables in the ARDL to construct the NARDL. So just like what we have in this slide. Yeah. Okay, what happened? All right. So here, this is an ARDL setting. We simply frame the asymmetry of the independent variable in this ARDL platform or ARDL model to form the NARDL. Okay, so we looked into the coefficient value to understand the long run as well as the short run relationship. Okay, so based on this ARDL model, click view, and then here choose label. Here we have this description. In the description or under the description, we put asymmetric variables. Yeah, asymmetric variables. Why? Nonlinear means our model is asymmetric. Asymmetry means positive variable or variable with positive values and variable with negative value present different impact towards the dependent variables. Yeah. And we choose the LRGDP as well as LWTI, the lag value of the real gross domestic product and the lag value of the fuel price, because these two are our independent variables. And then after that, you click enter. All right. So after that, in the add-ins, yeah, click add-ins. and choose make nonlinear ARDL model. Remember, okay, sometimes you may not have this ARDL add-in your EViews yet. So if you wanted to install it, you can simply click download add-ins. Yeah. Oh, okay. So this may take some time. So based on this add-ins, you can choose the NARDL model. Choose the NARDL model and then you click install. But since in this case our NARDL model is already installed, so I install it install it before this. So we don't have to click the install button. We can simply click close because it is already included in my add-ins. So in the add-ins, once you install it, go back to the add-ins and you will have these options. But remember, if you have or if you're using the latest version, the NARDL itself may be integrated already in the estimation. So there may be some differences between version 9, 10, and 11. So take note that there may be some different methods of conducting the NARDL, but that differences will not going to be significant, I believe. Yeah. So in the EViews 9, and if I'm not mistaken, in EViews 10, this is the same approach that we're going to use in order to test or conduct the NARDL. So as I said before this, once you install the add-ins for NARDL, click the NARDL again. Remember, you are still in ARDL here. Yeah, you're still here. Click NARDL, sorry, click add-ins, and then choose make nonlinear ARDL. Okay, so sometimes we have this problem, just like before this. All right, it's okay. Let us see what is the problems here. So sometimes we have that LWTI. All right, so now click add-ins, choose make nonlinear ARDL. Hope that it is okay this time. LRG, oh, okay, sorry. We have this one, GDP. Yeah, so when we, key in the, what we call as command or values in the EViews, make sure that we key in the correct values. Yeah. Otherwise, you may have that kind of, you may receive such notification saying that you have errors in the estimation. So here, let us run the add-ins again. Hopefully that this time it is okay. So we choose, click add-ins, click make nonlinear and make nonlinear ARDL model. So here we have the NARDL model. So this is the ARDL model itself, and we frame the asymmetry of the variables to form this NARDL model. So you can also see that the NARDL equation is automatically inserted in the work file. And not just that, in the work file, you can also see that we have additional variables. Yeah, we have the negative values and positive values of the independent variables included in the work file automatically. Yeah, negative values and positive values. So why is it is included in the model? Well, remember that in the nonlinear ARDL model, we are actually trying to see whether these positive values and negative value present the same impact or not in explaining the dependent variable. Okay, so from this NARDL model that we have, we can click view, and then after that, use coefficient diagnostic to find the long run form. Yeah, to choose or to check for the relationship between the variables in the long run. Click long run. And then after that, here we have the long run coefficient. In the long run coefficient, we have the relationship between positive and negative GDP as well as fuel price towards the food price. And of course, we have the probability value and the coefficient value as well. So based on the probability value, we can see that positive gross domestic product is significant in influencing the food price, while negative uh, gross domestic product is insignificant in explaining uh, the food price. Here you can see that there is an asymmetry between positive and negative GDP because they present different significance towards the food price, where positive GDP is significant while negative GDP is insignificant. And we can proceed with the what we call as fuel price. Here you can see that both positive and negative fuel price present significant impact towards the food price. And not just that, when you look into the coefficient, they are pretty much the same. Means that their influence towards the dependent variable, in this case, food price, is relatively similar. Yeah, relatively similar. So before we go to the error correction term, yeah, to study the short run relationship, another important analysis that we can conduct for both NARDL and ARDL, I forgot to show it before this, is to conduct the bound test. Yeah, to conduct the bound test. What is the bound test? If we refer back to this slide, I mentioned it here if I'm not mistaken. Okay, so this bound test here. What is this bound test tell? All right, this bound test will help us to determine, okay? It will help us to determine whether our variables are jointly significant in explaining the dependent variable in the long run or not. So this is an individual long run relationship of these independent variables towards the food price. Yeah, positive, negative for both GDP and fuel price individually. Yeah, so based on this individual long run coefficient, we can see that negative GDP is insignificant in explaining the food price. We can run, on the other hand, we can run the bound test to see whether these variables are significant or not to jointly influencing the food price. So we run the bound test to check for that situation or for that nature. So in order to run the bound test, click View. So here, check coefficient or click coefficient diagnostic and then check bound test. In the bound test, identify the value of the F statistics. Identify the value of the F statistics. Here you can see that the value of the F statistic is 7.12169. Okay, so this is the value of the F statistic. And we compare this value with the lower bound and the upper bound. Lower bound and the upper bound. Here you can see that the F statistic is higher than the upper bound at 10%. Since we are using 10% significance level, we use the same, before this, we use the same, what we call as rules as well, or assumption for this bound test. So here, our F statistic value is 7, while our upper bound value is 3.52. Obviously, our F statistic is larger than the upper bound. It means that our model is jointly significant in explaining the dependent variable. Or if we can rephrase it, we can say that our independent variables, yeah, positive and negative GDP as well as the fuel price are jointly significant. Jointly means they together, they influence the food price. So that is when our F statistic is higher than the upper bound. If the F statistic is lower than the lower bound, then it means that our variables or our independent variables are not jointly significant in explaining the dependent variable. So what if, for example, our value here, f statistical value, is between the upper bound and the lower bound? In that case, we can say that the relationship is undetermined. Yeah. So the joint long run relationship is undetermined. Because why? Because this bound test, as I mentioned before, this test for the joint long run impact of the independent variables in explaining the dependent variables. Okay. So that after that, we can proceed with the short run relationship. Yeah, we can proceed with the short run relationship. For that, we open the coefficient diagnostic again and look for the co-integration and long run form. In the latest version of EViews, you actually have the ECM hardwired in the estimation. But in the version 9, we don't have that ECM model hardwired in our estimation. So that is why we have to estimate the ECM manually. So how to run the ECM model manually or separately? Well, in order to do that, let us first go back into the ECM model here. So here you can see that the ECM model comprises of these important components, where here you can see that the dependent variable is a function of the difference form of itself in lag value, the difference form of the independent variable in current value and in lag values, as well as the error correction term in lag value. Remember, the error correction term shows the speed of adjustment for the model to move back into the long run relationship or equation when short run shocks occur in our model, in our estimation. So in order to run this ECM model to study the short run relationship for the nonlinear ARDL, we estimate the ECT first. What is this ECT? Well, here you can see that this ECT is equal to the difference between the independent variable, the intercept, as well as the estimated independent variables. So we estimate the ECT first. In order to do that, here in this co-integration and long run form, you can see that we have this co-integrating equation. So right click to copy. And here we can choose either as displayed or using highest precision. I think it is safe for us to put as displayed because 4 decimal point is quite safe already. We choose OK. So I hope that all of you are still here. Okay, so here we have on with another question about the serial correlation. If lag 2 shows serial problem, can we choose 5 or 6 until no serial correlation? Well, I think the safest way is for us to refer back to what the previous research say about this. Yeah, you can also refer to the Bruch-Pagan lag range multiplier assumption. Yeah, to choose whether to accept or not accept if your estimation has serial correlation problems in different lags. But for me, if say, for example, in lag 2, you have serial problems, then I think it implies that you have misspecification in the model. Yeah. So rather than changing the serial correlation lag values to suit your model that you have, I think it is better for you to modify the model itself in order to eliminate the problems of serial correlation. Because remember, serial correlation means that the present value of the error term is influenced by the 2 lags or 3 lags, 4 lags. So it means that there is a non-randomness in the error term. The randomness of the error term is very crucial, especially in the time series as well as the panel data analysis. We need to assume that our model is non-random in terms of the error term. Because if it's non-random, it means that there may be some omitted variables there. So these variables, as they are omitted, their impact will be recorded in the editor. So that is why we have that non-randomness. Yeah, we have that some sort of trend in the editor. Okay. All right. So let us proceed with the estimation of the ECM. And for that, first thing to do is for us to estimate the ECT, error correction term, the speed of adjustment of the model to move back into the long run relationship. So this ECT will help us, if we can back to this equation, this ECT will help us to see the speed of adjustment of the model to move back into the long run period after period. Yeah. So we use the same approach when we estimate the ECM for the ARDL model, okay? Where we copy this, again, the co-integration equation or co-integrating equation. Here, click Generate Series, choose Quick, choose Generate Series, and then you enter the equation, paste. Okay, so here, let us rename this co-integrating equation into ECT to make it more clear that this is referring to the ECT. Okay, and then after that, let us rearrange this equation to make it more neat, yeah, or presentable. All right, so I think that's it. We can click OK. I think it is saved already. Yeah, so here we have these additional variables created in the work file, which is the ECT. So here you can see the ECT form. Of course, yeah, for the first observation, the value will be non-available. Because why? If you look into this ECT, yeah, it records the lag values of the variables. So that is why in the first observation, the variable will be non-available because it is based on the previous value. Since we don't have that one, so the ECT will start in the second period of time. In this case, 1972. Okay, back again. So once we have created the ECT form, remember we are in the NR model. We are going to refer to this what we call as variable form. Okay, we are going to refer to this variable and in their form to construct the ECM model. It means that these positive, negative values of the GDP need to be in their different form. Yeah, different form. Remember that. So that is what it means by this equation here. For example, this, they refer to the difference form. Yeah. So to make it more convenient for us to run the ECM model, let us create these new variables. What are these new variables? These variables are the variables in their difference form. Because remember, when we run the ECM, it needs to be based on this same exact arrangement or same exact form. So yeah, the reason why I did not share you the Excel file is because I want you to focus on my what we call as an explanation here. So after this, before we end our session, I will share you the what we call as the Excel file so that you can run it on your own by referring to this. Yeah, by referring to this what we call as discussion. Or maybe I can I'll try to ask the help from Madam Elizabeth to share you the files. Okay, once the session has ended, don't worry about that. So yeah, in order to create, as been mentioned before this, you can either use command menu or you can also use the quick menu. So let us use the quick menu here and we create the additional variables. What are these additional variables? They are the difference form of the variables that we have here in this estimation. So we start with the difference form for the LR GDP first. So LR GDP. Before that, let us cancel so I can see this one clearly. Back again, generate series. So we follow this one. Okay, we follow this one. So DLR GDP positive is equal to the LR GDP positive minus LR GDP positive in lag 1. So that is how we obtain the difference form, by subtracting the present value with the previous value. So that is what we present here. And we repeat the same process for all variables included in the estimation. Okay. So here we have the value already. Okay. So we repeat the same process for the other regresses based on this co-integrating form. DLRGDP. So this is so that it will be easy for us to estimate the ECM analysis, or to conduct the ECM analysis. So difference LRGDP negative is equal to the LRGDP negative minus LRGDP negative in lag 1. So the current value of the GDP negative minus the previous value of GDP negative. So that is what it says here. So GDP, make sure that all are correct. Otherwise, you may create an incorrect equation. So this is a very crucial. So that is why it takes time to analyze ARDL model as well as the NARDL model. Okay. So imagine if you have 4, 5 independent variable, it will take time. Yeah. We repeat the same one. DLRGDP. No, DLWTI positive is equal to the LWTI positive minus LWTI positive in lag 1. Repeat the same thing again, this time for negative fuel price. Negative is equal to LWTI negative minus LWTI negative in previous value, or in lag 1. LWTI negative, constructed the LWTI negative in difference form. And then last but not least, we generate the series for the DLFP, which is the LFP in present value minus LFP in previous value, or in lag 1. Click OK. Right. So let us check whether the equation is correct or not. This time it is okay, because sometimes when we do this, sometimes we may face misspecification. LRGDP negative equal to LRGDP negative minus LGDP negative 1. So the LRGDP positive is equal to LRGDP positive minus LRGDP positive minus 1. It is important for us to double check this. So DLWTI negative is equal to LWTI negative minus LWTI negative negative 1. Positive is equal to positive LWTI positive -1. All right. Okay. So after that, let us check the ECT form. Here we have the difference form for the dependent variable as well. So that is why it is important for us to find the difference form for food price here. All right. So after that, so notice that the equation that we're going to form will be resembling this one. We have the ECT, we have the lag values for the dependent variable and the lag values of the independent variable in forming the area correction term or area correction model. So in order to do that, in order to run the equation, click quick and then generate, sorry, not generate series, but click quick, estimate equation. So now we proceed to the estimation of the equation for the ECM model, this one. Okay, so first one is the food price in difference form, LFP. And then after that, we include a constant term, and then we include the DLR GDP positive. And then we have DLR GDP negative. Remember, if you can see here, they are the same as the equation that we have in the co-integrating form. And then after that here, for GDP, it is negative at present until -2. So DLR GDP, this is for the negative LR GDP. -1, and the LR GDP negative in lag 2. And then after that, we have the LWTI, which is the difference form for the fuel price in positive as well as the fuel price in negative. So here you can see based on the co-integrating form, we don't have lag values for fuel price. Yeah, we don't have the lag values for the fuel price. This is for the short run co-integrating form. Yeah, so this is for the co-integrating form. Sorry. So you can also see, as I mentioned before this, we are forming this ECM model based on this co-integrating form. Yeah. And last but not least, here you can see that we have this ECT term, ECT. So this is the reason why it is important for us to construct the ECT variable as well. ECT, and it is in -1. Previous value of the ECT, just like what we have here. ECT in -1. Okay, so that's the reason why important for you to understand the function, econometric function, so that you can see what does it represent. So we can run this ECM by using the least square platform or least square estimation setting. But make sure before that we double check, make sure that we have everything in their correct shape already and we don't miss any important information. Okay, I think it is clear. We can proceed with this one. Okay. Oh, okay. See, if we have misspecification, yeah, if we have incorrect formula to say, it will be indicated there. So here, in this situation, we have one incorrect information. What is the incorrect information again? DLWI negative. Oh, okay. So it is this one. LWTI. Okay, so that's the good thing. This value over there. We choose okay. Now we have the short run form. So we can say this as the ECM for NARDL 1. Choose okay. So here we have the short run form for our NARDL. So you can look into this short run form to study the short run relationship between the dependent variable and the independent variable, including their asymmetry. So here we have the ECT. In this case, the coefficient value is negative, and it is not lower than -1. And you can also see that the probability is lower than 10%. Remember, in this discussion, we're using 10% significance level as an indicator to decide whether to reject or fail to reject the null hypothesis. So here, for the exact value of coefficient, we can see that the value is 0.582811. So it means that, and the sign is negative. When the sign is negative, it means that there is a model to move back into the long run when short run shock occurs in our estimation or in our variable. So here we have this value of 0.5828. So it means that any shocks that happen in the independent variable, it will be corrected based on the rate of 58.28% per period. Yeah, and it will take 1 over 0.5828. 1 over 0.5828, which is roughly 1.71. 1.71 period for the model to move back into the long run equation. So that is what ECT represents, that. So it shows the speed of adjustment per period of time. In this case, the speed of adjustment is 58.28%. When short run shock occurs and this equilibrium happens, that this equilibrium will move back into the long run relationship with the rate of 58% per period. Since we're using yearly data, so it will be corrected 58% in a year, and it will take 1.7 years for the model to move back into the long run equation or long run relationship. Yeah, if we refer to the bond test, we have long run relationship between the dependent and the independent variables. Oh, now it's 1:11:22 already. Okay, so apart from that, you can also check for the significance of these variables in the short run in explaining the dependent variable. So here you can see that for the positive GDP, it is significant in explaining the food price in the short run, since the probability is 10% or lower. Same goes to the GDP in negative value. It is also significant. Remember before this? Okay, so yeah, my mistake. In this case, for the positive value, we can simply refer to this probability to conclude its significant relationship with the food price, because we only have one coefficient value for GDP in positive value, okay, or positive GDP, because it only has this present value, or it only has one variable in this equation. But for the negative GDP, you can see that we have three coefficients from present value to negative up to lag 2. So we have to conduct what is known as the wall test to see whether these values or to see whether these negative GDP are significant or not in explaining the dependent variable. Why do we need to run the wall test? Because we have more than one variable to represent. We have a negative GDP. We have negative GDP at present. We have negative GDP in lag 1, and we have negative GDP in lag 2. So to run the wall test, click View, and then after that, go to the coefficient diagnostic and choose for wall test. So here, count for the coefficient that represent the GDP in negative. So here we have coefficient number 1, coefficient number 2, and coefficient number 3. So coefficient number 3, put it here. So this represent coefficient number 3 is equal to the coefficient number 4 equal to coefficient number 5. Because why? The coefficient number for negative GDP starts from coefficient number 3 until coefficient number 5. coefficient number 3 to represent the negative GDP at present difference. Yeah, because this is in difference form. Coefficient number 4 represent the negative GDP in lag 1, while coefficient number 5 represent negative GDP in lag 2, equal to 0. So we wanted to assume whether these coefficients, they are equal to 0 or not. When they are equal to 0, it means that these coefficients that we have in the ECM, LRGDP negative, they are not significant in explaining the dependent variable, which is food price, because they are equal to 0. If they are not equal to 0, it means that they are significant. But of course, to refer to this probability value, I can guess that it will be significant as well. But who knows? Let us see. So click OK. So here you can check for the probability value of the F statistic and chi-square. So here, obviously, we reject the null of 0 impact for the GDP negative at present, at lag 1 and in lag 2 in influencing the dependent variable. In other words, here we say that GDP negative is significant in explaining the dependent variable, which is food price in the short run. Because remember, we are running a short run relationship here, short run analysis. So after that, we can also check for the negative as well as the positive food price. So here, since we don't have the lag values, in other words, we only have one variable for the positive positive fuel price and negative fuel price. So we don't have to run the wall test, because if you run the wall test with only one coefficient, it will show you the same exact value. For example, we wanted to test the wall test for positive fuel price here. Sorry, I keep on saying, I keep on confusing the words food price and fuel price. So here we wanted to check whether this fuel price is significant or not in the short run by using the wall test. Yeah, so we count the number of coefficients for fuel price positive. 1, 2, 3, 4, 5, 6. So it is coefficient number 6. So we say that it is equal to 0. So this is our null hypothesis. So if we reject, it means that this positive fuel price is significant. So here you can see, yeah, that the probability value is significant. So it is the same as the probability value that we have in the ECM model itself. So it means that this model, this variable, the positive fuel price, is significant as well. And just like I mentioned before this, if we only have one coefficient value for a variable, you don't even have to run the wall test. Do so if you have more than one coefficient value. For example, in this case, we have this GDP negative here, which run from lag 1 to lag 2, as well as in the present value. So here, negative value of the fuel price is also negative. Is also significant because it is 10% or lower. It is in this case 8%. So we can say that this negative fuel price is also significant in explaining the movement of food price in the short run. So you can look into their coefficient value. Yeah, but sometimes you can simply understand the relationship by looking into the probabilities when you are conducting a short run relationship, because usually in a short run relationship, our attention is towards understanding the significance itself. Yeah, the significance of the relationship. Okay, apart from that, of course, we can run certain diagnostic tests, including serial correlation, heteroscedasticity, as well as the stability of the model. Yeah, so that is how we run the what we call as NARDL in the long run as well as in the short run. So this is based, there are a number of ways, yeah, for us to run the NARDL model actually. Yeah, that is one of the ways. The methods that I shown to you is one of a number of ways to estimate the NARDL model. Because apart from that, yeah, another method is by using what we call as the testable form. Yeah, so this you can achieve, or you can run the NARDL in short run as well as in the long run by using this testable form as well. So here you will automatically have the long run form, but the value will be the same as what we have done before. Yeah, so here we have the short run relationship and the long run relationship. Yeah, the long run relationship, they are not in their difference form. The short run relationship is indicated based on the difference form, just like what we have here. This is the short run, and this, on the other hand, is the long run. But as I mentioned before this, they present the same answer. Yeah, they present the same answer. So you can obviously refer to the method of NARDL and NARDL in the ECM form to check for the long run as well as the short run relationship between the variables, okay, by referring to the methods that I shown before this. So let me share you before I forget, not really sure whether we can share the more. Can we share notes here or materials? I'm not really sure. Yeah, because I'm not really that familiar with this, Webex. Never mind. Okay, I'll try to seek. I'll try to ask Madam Elizabeth whether if she can send you through the email. Yeah, the Excel file that we have over here, so that you can run this ARDL model on your own at home. Yeah. So any other question before we end our session? So we're supposed to end at 11 actually, but now we're already 11:32. So sorry for that.
Excuse me, teacher. I have a question.
Yes.
I'm sorry, I can't send a message in WeChat, so I use Mac phone. I just want to ask, what's the difference between core integration test and ARDL model?
The difference between
Core integration test and ARDL model.
Can you, because my line is breaking up, can you type the question in the chat box?
Yeah, okay. I just can send the message.
Because I only heard the words AARDL. What is it?
I mean, I just can send the message in personally. I don't know why. So I can.
Okay. It is okay. Okay. So your question, can you repeat it? Sorry for that. Yeah, because my line is breaking up. Yeah. So what is your question again?
Okay,
What is
thank
your
you.
question? Yeah. What is your question again? Sorry. You said about the ARDL and.
What's the difference between core integration test and
Okay.
ARDL model?
I see. All right. Okay. The difference between co-integration test and ARDL model.
Yes.
Okay.
Yes.
Yeah. Okay. Thank you for that. All right. So basically, this ARDL model is a type of co-integration model. Remember, co-integration model is used to study the long-run relationship between the variables. Yeah. So one of the method of conducting the co-integration analysis is through the ARDL model itself. Yeah. So that's what co-integration and ARDL model refer to. Yeah. So yeah. So that co-integration, it shows, or it tells us the long-run relationship between the variables. Yeah.
Yeah. Yes.
Okay. So I hope I answered your question. So any other question before we end our session? Because Madam Elizabeth said that she has another commitment. So but it is not an issue because we can still proceed. So if you have any question, you can just select for this. You can either put it in the chat box or you can also switch on your microphone. Yeah. So we try to spend until 11:40. If it is okay.
Okay, thank you, teacher.
All right. So any other question? If not, then I think if we don't have any question, I think I can simply end this session. But if you have, additional question, you can just email me also. Yeah. So anyone? Oh yeah, okay. So Madam Elizabeth also said that she is on handphone. Don't worry, Madam Elizabeth. Yeah, I can also handle the session here. Yeah, you can. You can proceed with with that commitment. Okay. Any other question, anyone? Okay, yes. You can also email me about the EViews. So if there is no other question, I think that's all for today. So do we need to do the what we call as do we need to take a photo for our workshop? Do you want to let me stop my sharing? If you don't want, then I think that's all. Okay, so I think that's all. That's all from me. Thank you very much, everyone, for tuning in, staying until 11:40. Nearly 11. Around, 2 hours and 40 minutes already, or 2 hours and 30 minutes about this ARDL and NARDL. Remember, this ARDL and NARDL, they are very exciting, and they are very exciting model. But make sure that before you proceed with the ARDL and NARDL, the assumptions regarding the variables are there, especially in terms of the stationarity level for the variables. You cannot proceed if the variables are stationary at the second order or at the second difference. Right? So even though that this ARDL as well as the NARDL are very significant, or interesting, actually they are quite, the number of analysis being conducted based on this nature is quite limited, including in the financial data. All right. So if you have the chance to use this ARDL and NARDL, I welcome you to do so. At least you can shed more light on trying to understand the relationship between the variables. Yeah. So I think that's okay. So again, thank you very much, everyone. Stay safe wherever you are. If you have any question, you can simply email me. Yeah, thank you very much as well to Madam Elizabeth for coordinating as well as arranging this very fruitful workshop. And thank you very much, everyone, for joining as well as staying until this time. Hope that this workshop is a very positive workshop to all of you. Yeah. So until we meet again, thank you very much.
Okay,
Oh,
thank you,
Waneli, you
teacher.
are still there. All right.
Thank you so
Okay,
much.
welcome.
Thank you,
Okay,
Dr. Saizal.
bye. Okay, bye-bye, everyone.
See you. Bye bye.
Welcome. Yeah.